everybody. This is Roy Francis, and you're watching another episode of Igniting American Manufacturing. And we talk about a lot of things in manufacturing and reshoring in the United States. And one of the things I talk about is we have some issues we need to address, and it's going to take a collaborative effort, and it's going to take government, it's going to take industry, and it's going to take academia. So representing academia today, I have Dr. Douglas Brauer from Florida State College at Jacksonville. Welcome.
Yeah, thanks for having me.
I'm looking forward to having a conversation here. And this isn't, people confused. This isn't an interview. I want to have a conversation. I want to have a little back and forth. It's going to definitely be a conversation. Yeah. I know you have a lot to share with us. So, and just share with us where you're from, where'd you go to school? Give me a little background.
Well, originally from Illinois, Chicagoland area, and got my engineering degrees from University of Illinois. Got my PhD from Colorado State. So that was kind of my pathway on that side. It's interesting in the two loves that I found in my life. I love manufacturing. Then I also fell in love with higher education. So started out adjuncting a class and just loved working with the diversity in the classroom. So half of my career has been in global manufacturing, and the other half has been in higher education. So that gives me a unique perspective on what we need to do on the higher ed side to make sure that we're providing the skills for the future workforce that's really going to carry on from you and I at some point.
I don't think that gives you a unique perspective. I mean, it gives you a great perspective. Something that we're really, having that insight and being able to say, hey, this is where it happens in the real world. This is what we really need.
And I think also along with that, the sense of urgency. All those business things that we talk about that have to be there. I bring that to the higher ed side, which is, can be very frustrating at times, which is why I've jumped back and forth at times. I've had enough. I need to go back and
I've worked I've done some work with higher ed, and in manufacturing, it's all about scaling and getting product out the door and sense of urgency, and you don't find that in academia. So
no, it's difficult. So.
I understand wholeheartedly. I've actually, I might have felt that pain once or twice too. So. So you're down here now at Florida State?
Yeah, we came down, 6 years ago, came down Florida State, and don't miss the snow in Illinois. The warmer weather's nice. So my wife and I, we've become Floridians at this point. But we've had a long history with coming down with other family that live down here. And
one quick question, Blackhawk fan?
Yeah, Blackhawks. Okay. Well, you're going to have
Original
baseball.
Six.
Yes, baseball. It's going to be, it's going to be the Cubs. That's that side of the house, and certainly the Bulls too. So.
Well, if you take a look at that monitor there, you see my last name, Comiskey. I had a ballpark out of the White Sox. I never saw any of that money though, but Comiskey Park's long gone too. But
that's changed. Yeah, that's changed. Yeah.
We're glad you're here because I know you're really contributing. There's a lot going on at the university. You have an advanced manufacturing center, is that correct?
We do. We have the advanced downtown campus, Advanced Technology Center. That's where we have a lot of our engineering programs associated with advanced manufacturing. So that's the hub for that. Along with that, within the engineering and industry department that we've got, group, we've got automotive technology, we've also got building and construction, we've got architectural design and construction, we've got the aviation programs that are out at Cecil Field, and we have other stuff that's scattered around.
You just started a robotics automation lab or something along those lines, did I get that correct?
Well, we've always had robotics there. So one of the things that for our engineering, where we do the advanced manufacturing courses, we have a group of 4 labs that really have all of the technologies in there. We've expanded that to an engineering innovations lab where we brought in a lot of additive manufacturing, so 3D printing, that kind of stuff. Mm-hmm. So we're expanding in all the areas, bringing in the things that need to be there, so we make sure that we're relevant. And it's very applied focus. So the technologies that are there, it's not getting hung up on the theory. That's not what we do. It's very application based. So when you start looking at things into the future, all of the components of Industry 4.0 and those things, we've really now latched on to artificial intelligence as being an integral part of that, and in part from the automotive programming that we have and our partnerships with JTA and Beep into smart technologies, the autonomous vehicles, that kind of technology. But in that industry, you find a lot of the same technologies run through the other programs. So it ends up being a nice, cohesive environment we have down there where students can jump in and take some of these courses on advanced technology, really independent of which program they're in. So we're trying to create that, be aware of the technology, all the sensing, the PLCs, the robotics, all of those kind of things, and how they work in different industries. So we're just not isolating it to one industry, but application across all the program areas.
I'm not the sharpest crayon in the box. I tend to focus on the last 2 years. I've been talking about smart manufacturing and smart factory and living plant, and I still do. But conversation, I think the conversation's changed a little bit. We need smart manufacturing needs to grow and iterate, and it is. But I find myself talking and reading a lot more about an urgent need inside there, robotics and automation. Yeah. And I was part of a delegation in China this summer, and right now the Japanese are number one in robotics, and Germany is number two. But China wants to be number one real quick, and they're really making a concerted effort. I watched whole lines of batteries, and it was the delegation was around the EV ecosystem, and I could see where they're really, really pushing it. Yeah. We're pulling out, we're kind of towards the back of the pack on that one. I think we realize that we're making efforts now. Yeah. Both the EU and the US are talking now to compete with Asia and to compete with wages in China and along those lines. That not only do we have to apply smart manufacturing, we got to apply a lot of those tools, which comes back to robotics and automation. I'm glad to hear you guys are doing it. You mentioned something. So at the end of the day, when we talk about robotics, and I had a gentleman in here, Win Harding, and he's talks about robotics and automation all the time. The basis for robotics and automation hasn't. Robots have been around for a long time. People don't realize that. Yeah. They're getting better and iterating, and they're getting more, precise. And we're talking about cobots. But the base, the base for doing that robotics work, and the base for smart manufacturing comes back down to an older technology, and it's iterating itself. PLCs and instrumentation and controls. Yeah. What is and you mentioned, tell me a little bit about what you guys are doing in the school along those lines.
And those are still critical elements, right?
Sure.
And it's all about the data collection and directing what's going to happen. Right. We've got, I think we have a series of 3 PLC courses that we do, and we've upgraded just recently. We had Alan Bradley was there,
sure.
but one of the things, we try to pay attention to what's happening in our backyard, the neighborhood, right? Mm-hmm. So when JEA did a big switch to Siemens controllers, we walked along with that, and so we brought in a bunch of that technology. So we have both technologies that are in-house, and we teach the kids through programming and diagnostics. The thing that again, as I said, we're very applied, right? So the focus is not on just creating engineers, but it's those people that are going to fix the things that are out there.
Sure.
Right. Which is a critical need, and huge opportunities in the workforce and make good money. But yeah, the PLCs that are all there, because that drives everything ultimately. And it's also done the data collection too. So one of the big focuses that we've had with all of this technology, you keep adding, LiDAR, radar, and vision, and all these things, right?
Sure, reality capture. Yeah.
It's the sensor fusion. So it's collecting all of this data, and what do you do, and how does it all work together? So we're bringing that into the curriculum too. So to create.
What is AI? So I'm hearing. I haven't seen it yet, and like I said, I talk about smart manufacturing and digital transformation. Yeah. And one of the problems, I wrote an article called "Fat Data," where we have all these instrumentations pulling all this data in.
Yeah.
Do we need all of it, or do we need all of it all the time? How do we truncate it? How do we get access to it? You know, it's that data collection and its suggestion. I haven't seen it yet that AI can sort through that and speed that process up. What are your thoughts there?
Well, two thoughts. You know, the data's always been there. You just haven't been able to collect it. You know, Henry Ford did a wonderful job in collecting all kinds of things, right,
Yep.
and optimizing his process. And that's really what, but it's within, you know, constrained by what he could collect and deal with. So when you look at the technologies today that can collect everything.
Yeah. And some people say we get fat data, or we get too much, overwhelming amount of
you
data.
get too much. And I think the issues that come to rise there are you looking at the right data?
Yeah.
If you're just looking at everything under the sun, you're not going to be able to make a decision, right? So that's where AI starts to help, right? It can start to digest all this stuff. But it's got to take some time for AI to give you the right answers, because if you can't challenge what an AI system is giving you, whether it's right or wrong, you got another fundamental problem, right? You're going to go down the wrong path.
Machine learning has a little piece of that too. I mean, there's a distinction between AI and machine learning. I think that eventually they're blending together quickly.
Well, yeah, and some of those where you know you can the cobots, those kinds of stuff where you can lead the machine through the steps, and you know it programs itself. That becomes where the human is still very much involved, and they can step away from it. And I think you're seeing that more in the processes that exist in Jacksonville. Some of the companies that are here are using you know all the robotic technologies and everything, and you know Amazon's notorious for all that stuff, and going beyond packaging, but now using that you know within the flexible manufacturing cells to guide things and make things happen. I think that. I think you're looking at all of this data that's there. You still have to sort through it. AI is another tool to help you sort through it, and until your AI system that you would have implemented really goes through iterations and learns itself.
Self-learning, and machine learning is self-learning as well.
Yeah, it's guessing. I mean, that's what AI is. It's probabilistic process, and so you want to reduce the risk, and the more data and the more that it's looking at, that's there. So our focus on AI, and we just launched this past fall, one of two schools in Florida. We have an Associate of Science degree in Artificial Intelligence.
So I'm going to start. I want to talk about that, and I want to talk about some of your other specific programs. I do want I want to go back to, you talked about the firms locally, so we'll do that here in a few minutes. But yes, I actually was looking a little bit about, it's an applied artificial intelligence associate's degree. That's wonderful. I think I want to go back. I always want to go back to school. I really think I want to take that course.
Well, you're not going to. So here's our focus, right? So we're really developing technicians to deal with the advanced technology. So the focus that I wanted to have with that is that we're looking at everything outside the box, right? Our kids are not going to be writing the algorithms that are inside the box, right? That's the kids come out of UF or whatever, that they're going to get
MIT or Stanford,
$400,000 or $500,000 a year, whatever, to do this stuff. That's not our kids, but you have to have somebody that can understand when something's not working. How do you diagnose the issues? How do you deal with it? So you have to have some understanding of that communication that's taking place between the AI box and everything outside of it, and it ties into the sensor fusion. So still being able to understand what's in there, to download data that's there, and be able to interpret, what do we need to do. They're not going to fix algorithmic problems or anything like that, but they can help diagnose, okay, what's happening outside that we need to fix so that we get the best decisions possible from the AI box. And that applies to any industry at this point, whether it's banking, manufacturing, aerospace, whatever, that's applying the AI tools. That you're going to need these people to be able to understand it and go forward.
I got a little story about that. I don't know if you're familiar with Ryan Messler. He was, one of the top guys at Tesla, and now he's with ABDC, American Battery and Technology Corporation. He's the CEO over there, and he really is trying to tackle that, the recycling part of the EV ecosystem. But when he was at Tesla, him and another gentleman, and I'm just going to name drops, Evan Horetsky, they're out at the utility yard, and trying to figure something out, and they've got an iPad, no paper drawings at Tesla. It was on the iPad, and they're going and they're scratching their head, and there's a gentleman, and I'm going to mention he worked for me. He's a tin bender by trade and a pipe fitter, and he's had his own pipe fitting business, and he's out there, and they can't find something, and they ask him where it's at, and he shows them on the drawing, and they're like, well, we need to do this, this, and this, and he goes, no, you do this, this, and this, and they kind of looked at him, and they walked off, and they had another problem, and they came back to him, and he goes, we need to do this. He goes, no, you do this, this, and this, and they're like, where'd you go to college? He goes, Hard Knocks.
Yeah.
They took him to dinner that night, and I hired him. So, but he was the guy, and I'm talking, Virginia Tech grad and a Stanford grad, right? Yeah. And they're standing there with a guy who's serving an apprenticeship, and they're listening to him, and they needed that guy. We need those guys writing those algorithms, but we need the Rusty Monahans. We need those, boots on the ground guys, and some of it's an apprenticeship, some of it's a certification, but we need those guys.
Well, I'll throw a number out at you, and this number comes back looking at data back to the world wars, right? 1 and 2, 127, and this has been through all of our labor force. It's been very consistent at the current day. For every one job that requires a master's degree or greater, there's 2 jobs that require a bachelor's degree, and there's 7 jobs that require an associate's or technical certificate. Okay. You're the kids that we're dealing with, and they all become my kids at some point. Mm-hmm. That's where the jobs are. It's not necessarily you have to have these advanced degrees, and that becomes more important when you're in a severe recession, right? Because companies have to be much more selective, and they can be much more selective. But the vast majority of jobs are still going to be at the technician level, so the associate's degree or technical certificates, something that's there or trade schools, whatever, you get something in your back pocket that you can go out and you can contribute right away in the workforce.
Well, I banter around, and some folks have picked it up. Manufacturing's cool, and there's a stigma that says it isn't. We need to change that. I think people are starting to realize it. But you're throwing out some numbers. Here's one. And when you bring a factory to town, and you put a factory worker in there, they'll create, and depends on who you ask, somewhere between 5 to 8, and some people say as high as 10 jobs in the community, from real estate, dentists, or vendors and all that. So manufacturing is good for a community. Those jobs also pay 25 to 30% more than the national average. So they're jobs in manufacturing and data centers and in the tech industry. They're good. They're about the American dream. Go buy a house, raise a family. They're good, solid jobs. And we do have that stigma, and we'll probably maybe come back to that. I do want to go back to, so you have your applied science. You have a couple more associate's degrees.
Oh, we do. We've got and they cross in engineering technology. So within engineering technology, you can get the advanced manufacturing, mechatronics, et cetera. There's a couple other
mechatronics, advanced technology.
Yeah, okay. So there's different technical certificates. Sure. So if you don't want to do the full degree, you can certainly take a chunk of that. As an example, we have the apprenticeship program with the Fleet Readiness Center at NES Jacks. Those kids that come through, they spend a year with us, and they get their technical certificate in engineing.
So these are Navy veterans that transitioning out.
No, they're civilians.
Okay.
But they've been hired by the Navy to go into their apprenticeship program. They run through and get a technical certificate, and then they go out and they get the real on-the-job training right out there in the facility out at NES Jack. So, so we do a lot of that stuff. So it's not necessarily the focus.
That's great workforce development.
You've got to get that even the 2-year degree, but start to put something in your back pocket, because once you do that, now you become hungry, right? So you know that the advancement is going to be out there. So you see a lot of those kids that come back and then will get their associate degree and then move on to get a bachelor degree from the college, and then look at where do I go, from here based on what I want to do. So
they take it piecemeal. They get the associates, and
you don't have to do it all at once.
And okay, that's great. Yeah. So you also have a building construction technology associate.
Yeah, we've got a building construction program there. That's doing wonderful, but it ties into a lot of the same thing. Again, we cross in there, additive materials, et cetera, things like that that are applicable. The aviation program out at Cecil Field out there. We have the flight program, but we also have the aviation maintenance programs that are out there. So, I mean, again, wonderful jobs to go out there. All of these kids, for the most part, they're either employed or they're already employed before they finish up their coursework through all these programs. So, and they're good paying jobs. I mean, that's the amazing thing. And some of these where, you know, the families would say, well, you don't want to do that. It's a dirty job. Well, not really anymore. I mean, everything is so
and that's
high
what we
tech.
said. You know, that's that stigma. You know, I had a gentleman on earlier today, and we talked. You know, you're not going to work in overalls, coming out covered in soap with your tin, you know, lunch pail and a lung full of some garbage.
Yeah.
These are really neat, and that's why I say manufacturing is cool. These are really neat places to work, and you're doing cutting edge work. They're interesting.
You know, one of the things that we just got, and I haven't talked too much about this yet, but we got a state of Florida capitalization grant. This came through.
I read that.
So we ended up about $2.3 million of that is for an advanced semiconductor manufacturing lab, which is largely all robotics.
Sure.
Obviously, we're not going to be making semiconductors there. You know, 2.3 is not going to get you in the door with that kind of equipment.
I don't know if you know that. I mean, I started in semiconductor. I hit my mic. I started in semiconductor about 40 years ago. It's where my heart is, you know.
Yeah. But we're picking up on that with the CHIPS Act. So we're taking, you know, we got that money. Well, we're going to have a brand new lab that is just all that process and all the automation with it. Sure. But the key thing is that now you can take that anywhere. You know, and all the companies that are popping up at the Commerce Center, you know, on the west side of Jacksonville, and even the ones that are down here in the heart of the city. All of these skills you can take to any company, and I always remind the kids, it says, you know, you get these skills in your back pocket and this knowledge. I want them to be transferable, right? So as one industry is up and another one goes down, if you're here, you jump into the one that's going up. So you always have that ability to put food on the table and take care of yourself. So that's really a driving force of what we're trying to do, is make sure, get everything out of it you can. And goodness gracious, what these kids are making, you know, some jobs that you would think are old dirty jobs. Have you been to a car dealership lately and see those repair bays? Goodness gracious. It's amazing, and they make very good money from the get-go, and so the sky can be the limit on what you want to do.
Sure. Well, you know, semiconductor has taken me literally around the world and around the United States. It's been wonderful. It's been good to me and my family. You know, you mentioned PLCs. You know, I think if you learn INC and PLCs, you can go anywhere. You know, and our Navy vets, you know, if you commissioned a nuclear sub and did the PLCs on that and ladder logic on that, there's no reason. That skill is directly transferable, you know, into manufacturing. So I was reading, and tell me a little bit of it. What, you know, I'm going to pose it as a question to you. Is your school military and veteran friendly? Tell me a little bit.
I think we just got a new designation that we're very. You have to be here in Jacksonville, right, with Mayport and everything that's happening here.
That was a softball question.
But yeah, we just got a new designation for that, but you know, we're always looking at that stuff. You know, the FRC, the Fleet Readiness Center, you know, the apprenticeship program is working with the military. I mean, they're our partners, and I can tell you that companies that are out there looking for people that have just wonderful skills and knowledge and experience and maturity, go find the military vets. I mean, they're going to slide right in and be up and running.
It's where Fusion ATG goes to recruit. Yeah. When I need INC people and I'm short, you know, they have, you know, the Navy has an acronym and a vernacular for everything, right? So does semiconductor and the EV sector. You know, if I can get them a thesaurus and get through the acronyms, it's the same stuff. They upskill really good. I want to go back, and like I said, you know, robotics is huge, and automation, and INC and PLCs. Certifications, or I came to you for INC. If I'm 20, coming out of the Navy, I'm 22 years old, and I say I want to get into robotics or INC or PLC. What are the offerings like? Am I going to get a cert or associates?
Well, a lot of it will be, the courses will be embedded into a degree, and within those degrees we'll have technical certificates, which is going to be just a portion, right, of the courses. You don't have to do the whole degree.
So I can come in and just and take the portion with
You
the
can come in and say,
cert-
I want to get this technical certificate because it gives me a real credential, right? Academic, I can put in my back pocket. And that may be, it depends on the certificates, but they could be anywhere from maybe 4 to 5, 6, 7 classes. You know, a smaller chunk versus trying to get 60 hours. You get something that's much smaller. You know, generally it's 15 hours or less, so it's very manageable. But along with that, we also have we look at industry recognized certificates. So it's coursework you're going through. You can go out and take national exams that would recognize industry certification. So we do a lot of stuff with NC3, and so they have a lot of electrical certificates and things like that as you're taking coursework and go along and pass these things. And you start to build up a whole portfolio of these certifications. The ASE for the automotive kids out there. Obviously with the aviation, they spend a lot more time, but they can go through and get their FAA license, you know, for airframe and power plant work. So we embed all of those types of opportunities along with the coursework. So if you don't want to do a degree or can't do a degree, a lot of our students are working, are already, right? But things happen. You got families and kids and all that kind of stuff. You can get something smaller and still have something that says, "Hey, I know this."
and go make some money, and if you want to go back to up for the degree afterwards. But you know, sometimes it comes down. And I'll be honest with you, you know, that's my story. You know, I started at college numerous times, and it was based on my work, and I started seeking out certifications. You know, and went back, you know, full time much later in life. So that's definitely my story.
It's a real pathway. You know, you don't have
to.
Yeah, you know, if you look at a comparison, even and there's nothing wrong with going to get a 4-year degree. I'm all for education, right? But you know, if you're looking for value add too, right? Yeah. So if you went to, you know, my daughter, my youngest one, I got 4 kids, but the youngest one just graduated University of Illinois, so it's a relatively recent hit, even though she's 30 at this point. But you know, you're talking these big schools, you know, 35,000 a year to go through. You can go get a bachelor's degree, right? So you're 120, 160. Get a bachelor's degree from a university, and there's value in that, right? It opens up doors. You can also get a bachelor's degree, for example, in business from FSCJ for less than 20. So, depending on what you want to do, what your ambitions are, goodness gracious, I mean, there's a lot of value in looking at your local community colleges and other trade schools, et cetera, that you can do things that would be very value added to your life and not break the bank.
FCJ, I mean, I don't know, maybe you guys call it community college. It's a pretty robust school. What's your student population?
Well, we've got 40,000 students.
Okay, yeah.
So we're not.
That's a big community.
We're not a small gig. You know,
not.
We've got 7 locations that serve everybody. As I said, we got over 150 programs. Within the career and technical ed side of the house, we've got 13 bachelor's degrees. So it's wonderful opportunities there in your backyard for the folks here in Jacksonville.
Well, we've touched on a lot of things. We talked about PLCs and the value of certs over degrees or somewhere in between. I want to go back to, and obviously you're very workforce development geared. I mean, that's what I'm hearing here. Yeah. Get a little more specific. We talked a little bit about some of the local manufacturers or some of the local employers here. What's your relationship with them? Are you working with them and working?
Yeah. So one of the things that we do with all of our programs, we kind of flip. You know, all programs will have an industry advisory council. Generally, you know, you go to the University of Florida, it's at your University of North Florida, the engineering programs, they'll all have an industry advisory board, right? We've kind of flipped it on the head. We have the same thing for all of our programs. but we flipped it. We've now moved to a business and industry leadership model. So instead of the traditional where the school, we would just vomit back at you, this is what we're doing. Now it's flipped. So it's, what do you want us to do? What are we missing? What needs to be out there? What's not in the curriculum that needs to be there? What are we missing in the laboratories? Going through that process and absorbing that, and then making sure that our curriculum that we have is relevant. If it's not relevant, why would you hire our kids? It doesn't make any sense. So we do flip this. So with all of our programs, we have a business and industry leadership team. And each of those would have anywhere from, it depends on the program, but up to 10, 20, 25, 30 companies that are participating, that we really pull to say, hey, let us know, what do we need, what are we missing, what do we need to do to improve, to give you the workforce that you really need. We don't just want to throw kids out on the street and say, boom, here it is. Tell us what you need. So when you look at big companies, and they're all different levels, right? So the things that I was doing globally in manufacturing, some were much more sophisticated than some of the other things that is manufacturing, right? But at Johnson & Johnson, highly automated, very sophisticated. I'm flipping to the other side, a relatively new company, Jinko Solar, very sophisticated in what they're doing. Medtronics, et cetera, all of these, they're using very sophisticated processes, but they still end up being very, if they're not fully automated, there's a lot of processes that are still, not fully automated. So you have to have that human being there that becomes the expert that makes things happen. So, you look at different aerospace companies that are here working with the military, a lot of water jet machining, things like that. So you're bringing in all these technologies that students need to be aware of depending on where they want to go. And we make sure that they get into the right coursework so they're going to experience the things. And that's, again, is where you look at, when you talk to the companies, what are we missing? Tell us what kind of equipment do we need to go after. If you can't give it to us or help us buy it, then I've been very aggressive in going after grants so that we can go out and get that and get it in-house and get the kids to touch and feel it and understand the technology. There's still going to be the on-the-job training, right? That's always going to be there. But if you understand, what it is, the technology, how it works, goodness gracious, how to turn on the machine, what it looks like when you go out to the floor, that's a huge benefit. And that's what you'd miss in a lot of the universities in engineering programs. It's way theory, and they don't get the hands-on, and they really don't understand. They got to really learn an awful lot about the application of the technologies.
Tell me if I'm wrong, and I agree with you. And and I talked about the German dual track system where techs and engineers go to school together. I think the pendulum's swinging. It's moving in the other direction. I think some of the universities and some of the bigger universities struggle with it, but I think a lot of the universities are starting to take a look at that, which is a good thing. What you said was or my heart. I always talk about, like I said, academia, government, and industry working hand, and without that feedback from industry, you're right, the curriculum doesn't match it. So putting that effort in, that's applaudable. And it just, it's pragmatic. It makes sense.
Yeah.
It just makes sense. So
yeah.
We are reshoring and bringing manufacturing back here. I'm going to wrap up here. We are reshoring and bringing manufacturing here, and to do it and be competitive, we've got to embrace the technology. Yeah. We've got to have that collaboration between those three entities. Working together, and we can accomplish a lot. Manufacturing played a huge role in making this country what it is. We lost a little bit of that edge, and I think we kind of realize it when we're working towards it. So what you're doing over to school is amazing. I'm going to invite myself over to come look at some of your labs.
You're always welcome, yes, please
and maybe talk to some of your students and just see all the wonderful things you're doing. And we're going to have you back, but we're going to wrap up here. So everybody, this is Rory Francis, and you watched another episode of Igniting American Manufacturing, and we'll see you soon. Thanks.